Hello, this is the Code Critics. In this episode, we are looking at code complexity, how it negatively affects data science and machine learning projects, and present the three-bucket approach as a solution. If your code gets too complex and too messy, then this is for you. Let us see how code complexity affects productivity by plotting a graph. On the x-axis, we have time, and on the y-axis, we have functionality. In the early stages of a data science project, when the codebase is small and simple, we can implement a lot of functionality in a short amount of time. We don't care about clean code and don't waste any time on refactoring or other efforts to manage code complexity. Life is easy and progress is fast. Let's call this the happy phase. If the project does not grow beyond a certain size, all is good, and we can successfully complete the project within the happy phase. If, however, the project continues, the code becomes more and more complex. Suddenly bugs appear. Long-range dependencies cause the code to break in unforeseen ways. We start to see code duplication, and changing or extending the code becomes more and more annoying. Progress slows down, and we enter the critical phase. We might still succeed, but the code is a mess. It was painful and it took a lot of time. Also, the code is pretty much non-reusable and so embarrassing that you don't want to show it to anyone. If the code grows even further, we are entering the sad phase. Any change to the code now requires tremendous effort and time. At some stage, we essentially hit a wall of complexity, and it seems easier to throw the entire code away and start from scratch. So, how do we get around this problem? How can we break through the complexity wall when the project increases in size and complexity? An obvious approach would be to enforce proper software engineering practices from the very start to manage the growing complexity. We would progress at a slower but steady pace, and since we manage the complexity, we would be able to break through the complexity wall. However, following this approach, the blue line, we would also lose all the gains in speed we achieved in the early stages of the project, during the happy and critical phases. Furthermore, maybe we can complete the project within the happy phase. It is hard to tell at the start, and then all the software engineering effort would have been a complete waste of time. Here comes the good news. For data science and machine learning projects, we can use a three-bucket approach that combines the best of both worlds: the speed of the early phases and the power to handle complexity that the software engineering approach provides. Let's have a look at it. In the early stages of a data science project, the happy phase, most of the time and code is spent on data cleaning. This code is inherently messy, since it has to handle all the special cases in the data. Wrongly formatted strings, missing data points, inconsistent records, and so on. In general, this code is largely non-reusable and runs only once. When the data is cleaned, we never use it again, and new data usually means new cleaning code. We are going to put this data cleaning code into a quick and dirty bucket. It is usually a smaller piece of code, not used by any other code, and we therefore do not waste any time on best software engineering practices. The second phase, the critical phase, is when we typically start writing code to pre-process, analyze, and visualize data. If it is a machine learning project, this is where we also start training and evaluating of models. Some of the code written in this phase is fundamental and very reusable. For instance, feature extraction methods. Others, such as plotting, not so much. And here comes the trick. The non-reusable code we clean a bit and put into an analytics bucket, while the reusable code goes into a third bucket, the library bucket. The code in the library bucket is well written, documented, tested, and of high quality in general. While this takes considerable time, it pays off in the long run, since every time we reuse this code, we save time. Most importantly, the high quality of the library code allows us to break through the complexity wall. So every time we write a piece of code, we make a decision. Is this code likely to be reused? If so, it goes into the library bucket. If not, it either goes into the quick and dirty bucket, if it is data cleaning code, or it goes into the analytics bucket. How are these buckets realized in practice? Let's have a look. Each of the 3 buckets will be a folder on the file system. The quick and dirty bucket is a folder that contains the raw data and the code for the data cleaning. This code might be a shell or Python script, Jupyter notebook, or whatever it takes to get the job done. The amount of code tends to be small and code quality is of little concern, but speed is. The library bucket contains the fundamental reusable code, developed following the best software engineering practices. No dirty code is permitted there, and any code needs to be cleaned before it can move into this bucket. The library is typically realized as an installable Python package with good documentation and possibly unit testing. This package tends to contain most of the code of the project. In the analytics bucket, we can now use the clean data originating from the quick and dirty bucket and the clean and robust code from the library bucket. Since all the hard work was done when filling the quick and dirty and the library bucket, it is now easy to write data analytics code and avoid the mess we had before. Analytics code might be a Python script, a Jupyter notebook, or even a proper Python package. And the code quality will be somewhere between quick and dirty and library code. Let us summarize. Data science and machine learning projects tend to experience 3 phases: happy, critical, and sad. The increasing complexity of the growing code over time and phases will reduce project progress to a standstill. We are essentially hitting the complexity wall, if complexity is not managed. One way to manage complexity is the 3-bucket approach, where we treat data cleaning, analytics, and library code differently. This gives us overall decent code quality, good development speed, and avoids the complexity wall. And that's it. Thank you for listening.